In part A of question 1, I'll just substitute y with minus 2. So I've got w equals 5 times minus 2 squared minus minus 2 to the power of 3. Just put this on the calculator and the answer comes out to be 28. In part B, the common factor is 2p, and I'm left with 4p minus 1. In part C, expanding will give me 12t squared minus 8t. And finally, in part D, I get 5x squared plus 20x minus 2x minus 8, which simplifies to 5x squared plus 18x minus 8. For question 2, recall that the area of a circle is given by pi r squared. In this shape, I have a rectangle minus a semicircle, which will give me the shaded area. Now, the radius of the semicircle is 6, since the diameter is 12. Let's write this down. And also know that the radius is any distance from the center to the edge. So this distance is also 6, which means that the height of the rectangle is 6. Hence, the area of the rectangle is 6 by 12 minus half pi 6 squared for the area of the semicircle. This will give me 72 minus 18 pi, which is 15.5 centimeters squared. In part A of question 3, I need the intersection of A and B. These are the common elements of A and B, and these are 24 and 30. Now, A dash means that I need all the elements that are not in A, but are in the universal set, and these are the elements 21, 23, 25, 27, and 29. Now for part B, it might be useful to draw a Venn diagram. Now the common elements are 24 and 30. In A, without the B, I've got the 22, the 26, and the 28. Then in B only, I have the 21, the 27, and I'm left with 23, 25, and 29, not belonging to neither A nor B. Now, set C are the elements outside of A and B, and these can be written in two ways. You can either think of this as A union B dash, or A dash intersection B dash. Both of these are equally accepted. In question 4, part A, the power of 4 applies both on 3 and on k squared. 3 to the power of 4 is 81, and then for the k, I will multiply the two powers, so I get k to the power of 8. For part B, I have division. 21 divided by 3 is 7. Regarding m, I only have this on the first term. There's no m on the second one, so it's going to stay as m to the power of 4. And then for the n, I need to subtract the powers. The first term has a power of 1, the second a power of minus 5. So 1 minus minus 5 gives me a power of 6. In part A of question 5, I need to rotate shape P 180 degrees about the point minus 3, 2. To rotate the shape, either use tracing paper or connect any point of the object to the center of rotation. For example, I will take this point here. This is exactly 7 units below the center. Now take this red line and rotate it 180 degrees about the center, and you will end up here. So this is the point corresponding to this point here. Now that you know that point, you can easily draw the rest of the shape. If you're not sure, you can repeat with another point. For example, let's take this point here. This point is 3 units to the right, 4 units below the center. So if I rotate these red lines 180 degrees, they will end up 3 units to the left and 4 units up, like this. So here is another point on the shape. So now you can draw the rotated shape that looks like this. In part B, I need to translate the shape P by the vector 10, 8. Now the top number indicates the horizontal movement, so that's 10 units to the right because it's positive. The number below indicates the vertical movement because it's positive, that's 8 units up. So I'm going to take this shape and take it 10 units to the right and 8 units up, and it's going to end up here. Now for part C, I have these two shapes and the transformation from T to U. Obviously, the shape changes size, so it's an enlargement. Now to find the scale factor, just measure any of the sides of the object and the corresponding size of the image. For example, take the height. I'm going from 2 to 4. So 4 over 2 is 2. This is my scale factor. And we need the center of the enlargement. Now to do so, I will connect two sets of corresponding vertices. For example, I will connect these two, extend the line, these two, extend the line, and see where those two lines meet. Now, these lines meet at -3, 3. Hence, this is my center of enlargement. For question 6, since there's an increase of 5%, this implies that there's a multiplying factor of 105 over 100. As a decimal, this is 1.05. Hence, Monday's price times 1.05 will give me Wednesday's price. So Monday's price is Wednesday's price over 1.05. That's 1.26 over 1.05, which comes out to be 1.2. Now this is for 1 liter, so for 30 liters, I'm just going to multiply 30 by 1.2, which will give me 36 pounds. That's my final answer. For question 7, this diagonal line is the line y equals to 3x minus 2. Now this horizontal line here is the line y equals to 1, and this vertical line is the line x equals to 3. Now the shaded region is below this line, hence the corresponding inequality will be y less than or equal to 3x minus 2. The region is to the left of the line x equals 3, so the corresponding inequality is x less than or equal to 3. And finally, the region is above the line y is equal to 1, so the inequality will be y bigger than or equal to 1. For question 8, I need the ocean with the greatest length. Now note that these two have a power of 5, so it's one of those two, and out of those two, the Pacific is the one with the biggest number. So the answer is Pacific. And then for part B, I'll just subtract 1.119 times 10 to the 5 minus 1.797 times 10 to the 4. Now the calculator can do this for you. So the answer will be 9.393 times 10 to the power of 4. Question 9 doesn't specify how to solve this equation, so I can do it either by factorization, completing the square, or using the quadratic formula. I'll do this by factorization, so x minus 20, x minus 1 are the two factors. So the two solutions are either x equals to 20 or x equals to 1. In question 10, I will need two extra columns. One of them will be the midpoints, and the other one will be fx, where f is the frequency and x are the midpoints. Now note the x I'm using here has nothing to do with this x here. So the midpoints are 1, 3, 5, 7, and 9. And then fx, I'm just going to multiply these numbers. So x times 1 is x, 33, 40, 42, and 45. And then to calculate the mean, I will just do sigma fx over sigma f. Now sigma fx is the sum of this column, sigma f is the sum of this one. So for sigma fx, I will add x plus 33 plus 40 plus 42 plus 45, which is 160, plus x, and then the sigma f is equal to x plus 11 plus 8 plus 6 plus 5. This is equal to 30 plus x. Hence, the mean is 160 plus x over 30 plus x, and this must be equal to 4.25 according to the question. So if I cross multiply 160 plus x equals to 127.5 plus 4.25 x. If I rearrange, I will get 32.5 equals to 3.25 x. So x is equal to 32.5 over 3.25. So x comes out to be 10. For question 11, recall that the length of an arc is given by the following formula. Now in our case, we don't need the 40-degree angle, we need the rest, and this is equal to 320. Hence, the perimeter is given by 320 over 360 times 2 pi times 9 plus the two straight lines here, so plus 9 and plus 9. And if you put this on the calculator, you will get 68.3 centimeters. In question 12, I will use elimination to solve the simultaneous equations. I'll multiply the first one by 3 and the second by 7. This way I'm going to make the y's exactly the same. So 6x plus 21y equals 51, and 35x plus 21y is equal to minus 7. Then I will subtract the two equations and the y's will cancel out. Now 6x minus 35x is minus 29x, and then 51 minus 7 will give me 58. So x is 58 divided by minus 29, that's minus 2. And now I'm going to substitute this x into any of the equations. I'll select the first one. So I will get 2 times minus 2 plus 7y is equal to 17. So 7y is equal to 21. So y is equal to 3. So my final solution is x equals minus 2, y is equal to 3. In question 13, I will work with the following right angle triangle. Now the angle of depression is 23, so this angle here is 23. The hypotenuse is 500, and I want to find the height of this triangle. I've labeled this as x, that's the opposite side to 23, hence sine of 23 is equal to x over 500. So x is 500 times sine of 23. This will give me 195.4 meters. In this question, I start with a decrease of 15%. Hence, my first multiplying factor is 85 over 100, or 0.85. Then I have an increase for 2 consecutive years, but I don't know the multiplying factor. And the overall change is a positive change of 2.85. So that's a multiplying factor equal to 102.85 over 100. As a decimal, that's 1.0285. Hence, the initial value times the 0.85, which is the initial multiplying factor, times the second multiplying factor to the power of 2, because that is for 2 years, will give me the final value. And I'm being told that the overall change, so if I multiply this, I will get the 1.0285. So let's write this down. 0.85 times the unknown multiplying factor square will give me the 1.0285. So the multiplying factor squared is equal to 1.21. Hence, the multiplying factor is the square root of this number, which comes out to be 1.1. Now this, as a fraction, is 110 over 100. So we're talking about an increase of 10%. For question 15, note that the two numbers are not necessarily consecutive. So I'm going to use the following to represent the two odd numbers. So if I multiply them, I get 2m plus 1 times 2n plus 1. And now, if the result is an odd number, I should get something like 2 times something, whatever that something is, and then plus 1. So let's see, expanding them gives me 4m times n plus 2m plus 2n plus 1. And then I can take a common factor of 2 from here. So 2 times 2mn plus m plus n plus 1. Hence, the answer is odd. For part of question 16, you can label the central region as x, and then the left region will be 62 minus x, because the whole of A is 62. Similarly, because the whole of B is 30, then the right region will be 30 minus x. Now, the union of these three regions is equal to 68. So 62 minus x plus 30 minus x is 68. So 92 minus x is 68. X comes out to be 24. So the central region is 24. The left one is 38. And the right one is 6. Now the total must be equal to 80, so the outside region is 80 minus 68, which comes out to be 12. Now you can find this one in a much faster way by recognizing that if these three regions are 68 and then these two are 30, you are left with 38, and then you can figure out the other two. Now the second part, BI, wants the probability that this element is A intersection B, so that's the central region. That's 24 out of 80. If you want to simplify, it gives you 3 out of 10. And then the last part, A union B dash. Now for this one, consider A are these two regions. B dash is the region outside B, so it's the outside and this one. And because it's union, I need any color, so blue or red. So the probability is the sum of the three regions, so 38 plus 24 plus 12 over 80, so 74 out of 80. You can simplify this to 37 over 40. In question 17, part A, start by finding G of 3. This is equal to 3 minus 10, which is minus 7. And then proceed by finding F of minus 7. This is minus 7 squared plus 6, which is equal to 55. In part B, I'll first find f g of x. I'll do so by substituting x with g in the f function. So I will replace this x with x minus 10. So I get x minus 10 squared plus 6. Now, in the next step, I'm going to equate this to f of x, which is x squared plus 6, and solve this equation. I will expand the left-hand side, so x squared minus 20x plus 100 plus 6 equals to x squared plus 6. I can cross out the x squares in each side and also the plus 6. So I'm left with 20x equals to 100. So x is equal to 5. Part C, I need to state the values of x that cannot be included in the domain of h. Now the problem arises if the denominator is 0. So this is the value I'll need to exclude. And finally, for part D, I need to find the inverse. So I'll start with function h. I'm going to replace hx with x and replace x with y. So I have x equals 2y minus 4 over y. I will cross multiply, so xy equals 2y minus 4. I will take the minus 4 to the left, the xy to the right, so 4 equals 2y minus xy. Next step, take the y as a factor, and finally divide by the brackets. Hence, my inverse function is 4 over 2 minus x. Now, note that this is equivalent to writing the following. So both of these are accepted as the inverse function. In question 18, I'll start by factorizing the second denominator. So 5 over x plus 2 plus 3 over x plus 2 is equal to 2 over 1. So the lowest common multiple of the denominators is x plus 2. I'll multiply the first fraction by x, the second one by 1, and the third one by x plus 2. So this will give me 5x plus 3 over x x plus 2 is equal to 2x x plus 2 over x plus 2. Now note the denominators will cancel out, so if you don't want to write them in the first place, you can do so. Then let's expand the right hand side. 5x plus 3 equals 2x squared plus 4x. This is a quadratic equation. I'll take everything to one side. 0 equals 2x squared minus x minus 3. And now I'm going to solve this equation either by factorization or using the method of completing the square or by using the quadratic equation. I'll go on with factorization, so 0 equals 2x minus 3 times x plus 1. The first bracket will give me 3 over 2. The second one will give me minus 1. So 3 over 2 and minus 1 are the two solutions. For question 19a, note that I have to write everything as a power of 2. So 8 can be written as 2 to the power of 3 and 4 as 2 to the power of 2. Further, note that I have a cube root here. A cube root of something is equal to that something to the power of 1 over 3. So now I can begin simplifying. 2 to the power of 3, everything squared, times the cube root of 2 squared to the power of 6. Now I will multiply these powers, so I will get 2 to the power of 6 times 2 to the power of 12, and then the cube root can be written as 1 over 3. Again, I will multiply these powers, so 2 to the power of 6 times 2 to the 4, and finally I will get 2 to the power of 10. For part B, I will need the following two rules. X to the power of minus a is equal to 1 over x to the power of a. And the second rule I'm going to need is the following. If x to the a over b is equal to y, then x equals y to the power of b over a. So using these rules, I can first flip this one. So it's going to be 1 over n to the power of 4 over 5 equals, and then 1 over 2 to the power of 4 is 1 over 16. So then I'll proceed using my second rule. 1 over n equals 1 over 16 to the power of 5 over 4. You can do the right hand side on the calculator. It will come out to be as 1 over 32. So since 1 over n is 1 over 32, n must be equal to 32. For question 20, I will need the following two formulae: the area of the sector and the area of the triangle. The second one is given at the formula sheet at the back of the cover. Now I will need angle theta, and this is also angle C, and this is basically this angle here. Now this angle is 150, and the reason is that angle at the center is twice the angle at the circumference. Also note that the letters A and B, C used here do not correspond to the letters A, C, and B here. So the shaded area is equal to the area of the sector minus the area of the triangle. So 200 is equal to 150 over 360 pi r squared minus 1 over 2. And now since I'm going to use the 150 degree angle, I will need the two sides A and B that are adjacent, and these are these two sides Here, these are radii, so I'm going to have here 1 over 2r times sine of 150. So 200 equals to 5 over 12 pi r squared minus 1 over 2r squared, and the sine of 150 is 1 over 2. Let's simplify this. 200 equals to 5 over 12 pi r squared minus a quarter of r squared. So 200 equals to r squared, and then I'm left with 5/12 of pi minus 1 over 4. So r squared is equal to 200 divided by this number, 5 over 12 pi minus a quarter, comes out to be 188.8 and so on. So r is the square root of this number, which comes out to be 13.7 centimeters. For question 21, since there are 6 r, then there are n minus 6 blue, where n is the total number of bits. Now, assume you have a tree diagram, although you have to draw this. I will do it for you to understand. So consider this tree diagram. The probability of getting a red is 6 out of n, and the probability of getting a blue is n minus 6 over n. Now, if the first one is red, the probability of getting a second red is 5 remaining reds over n minus 1, which is the total remaining after picking one of them. And the probability of getting a blue one is n minus 6 over n minus 1. Now, similarly, if the first one was blue, the probability of getting a red one is 6, because the reds remain the same, over n minus 1. And the probability of getting a blue, that's where the trick is you need to subtract 1 blue, so n minus 7 over n minus 1. Now, the probability of getting a same color is the probability of getting a red and a red, so the product of these two numbers, plus the probability of getting a blue or a blue, so the product of the two numbers below, and this is 9 over 17. So let me write this equation down. 6 over n times 5 over n minus 1 plus n minus 6 over n times n minus 7 over n minus 1 is equal to 9 over 17. Now let's simplify the left-hand side. 30 plus n minus 6 n minus 7 over n minus 1 is equal to 9 over 17. Let's expand the numerator. 30 plus n squared minus 6n minus 7n plus 42 over, and let's expand the denominator as well, n squared minus n equals 9 over 17. I will simplify the numerator now. N squared minus 13n plus 72 over n squared minus n is 9 over 17. Now I will cross multiply, so 9n squared minus 9n equals to 17n squared minus 221n plus 1224. Let's take everything to one side. 0 equals to 8n squared minus 212n plus 1224. I'm going to divide these by 4. 0 equals 2n squared minus 53n plus 306. Now you can solve this either by factorization, completing the square, or using the quadratic formula. Now I used factorization and got the following: 2n minus 17, n minus 18 So my n value was 17/2 or 18. Now n is the total number of bits, so I'm going to reject the 17/2. N has to be an integer, so n is equal to 18. In question 22, I have two triangles. The triangle MBC is lying on the floor, and the triangle BTM is a standing one where T is vertically above B. Now I will extract the blue triangle and use it to find the side BM. Now this triangle is an isosceles one, so I have split it into two right angle triangles. So working with half of this triangle, I can use cos of 70 equals BM, which is the adjacent, over 8, which is the hypotenuse. So BM equals 8 cos 70. As a decimal, BM is 2.736, and so on. And then if I take the red triangle, which is the standing one, I will get the following. Hence, to find angle M, I'll do tan of M equals opposite over adjacent. So M is the inverse tan of this number. And if you put this on the calculator, you will get 74.7 degrees. And that's my final answer.